question asks us to rationalize why this electrophilic addition to an alkene gives two regioisomeric products, when typically the reaction of a mineral acid across an alkene gives only one regioisomeric product. It has to do with the substitution of each of the carbons in the alkene. They're both the same substituted. It's a tetrasubstituted alkene. So when this alkene reacts with HCl, the alkene can act as a nucleophile, and it can attack the hydrogen, kick out the chloride as a leaving group. We'll form a bond to hydrogen on one carbon, and we'll leave behind a carbocation on the other carbon. Now, Markovnikov's rule says that the most stable carbocation intermediate will be the one that forms. And if we think about the carbocation that could form at either of these positions, they would both be the same substituted. They would both be the same favorable. They would both end up being tertiary carbocations. So there's no difference between the carbocations, which means both carbocations could form without preference. We could end up with the carbocation at this position or the carbocation at this position. Since they're both tertiary, they both form with equal probability. Then the chloride could attack, and we would end up with these two products without any preference for one over the other.